Tape measures vary, but they will usually have a rugged outer case and sometimes they're rubberized to handle impact, like this one. This one is not rubberized and is less durable. Let's do a test. First, the heavy-duty rubberized tape, and now the less durable one. Most tapes have a width printed on them. This is so you can use the body to complete a measurement. You can see here it's 19, and if you add the 3 inches, you get 22. Most tape measures have a belt clip. This can be used on your pocket, or your belt, or anything else the clip will fit. The clip is usually installed with a single screw and can be removed if you prefer. I do this for tapes that will always be in my tool belt. Metal plates can be installed for use with a magnetic rail. Some tape measures are in the locked position by default. They must be released every time you want the tape to retract. The other type must be locked after extension. This makes it much easier for hands-free measurements. The lock also allows you to set a distance so you can scribe a line. The hook. The hook allows you to pull from the edge of the thing you're measuring. Some hooks have tabs on the top that will allow you to approach and hook from the underside. The hook moves slightly, making up for the thickness of the hook during pushing and pulling measurements. Here's an example of a 6-inch block, both pushing and pulling. It's important to inspect the hook from time to time to check to see if the rivets are loose and to see if the hook is bent. The hook slot is designed to fit a nail head and helps keep the tape measure in place while measuring. The nail is driven into the wood with the shank of the nail in line with the measuring line, and the hook slot is placed on the head of the nail. Not all hook slots are the same. Wider is usually better. If you're working with someone else and you both have a tape, you should check to see if they're measuring the same. This usually only matters when you're doing work that requires close tolerances. The blade of the tape measure, usually made of spring steel, has a cupped shape. Because of this, it has a unique property of being flexible in one direction and rigid in the other, allowing for some degree of extension before collapse. The blade, being flexible in the other direction, can be used to measure in tight corners and around curved objects. Generally, wider blades allow for more extension. This blade is 3/4 of an inch wide and can extend to about 57 inches. This blade is 1 inch wide and has a little more curve to the blade, and it extends out to about 115 inches. This is a Stanley Fat Max. It's 1.25 inches wide, and it extends out to about 11 feet. This one broke at 130 inches. If you put a little arc in your blade, you can extend a lot farther. The length of the tape is on the outside of the case. If the label is missing or worn, you can find the length listed on the end of the blade in most models, right near the end. I checked a few of the tape measures in my shop and they all had some sort of indication. If you want to put your name on the tape, a good place is all the way near the end of the blade. This is because it's less likely to wear and become indiscernible. The imperial tape measure starts at 0, which is located at the hook, and counts up to 12, where you'll find the 1 foot mark indicated with a black arrow. Beyond that, every consecutive foot is indicated in a similar fashion. The inch numbers will count up for the rest of the tape. You'll notice there's another set of numbers, usually printed in red. These are the number of inches beyond the preceding foot indicator. Sometimes the foot is indicated also. For example, 15 inches would be read as 1 foot and 3 inches. And 27 inches would be read as 2 feet and 3 inches. This option is here because building plans in North America often list a combination of feet and inches for dimensions. In North America, the construction industry has a convention for spacing framing members. Wall studs, floor joists, roof rafters, and trusses are all spaced according to this convention. Building materials such as 4x8 sheets of plywood for walls and for floors or drywall work with this convention. Typical spacing can be every 12 inches, indicated by black arrows, every 16 inches, indicated by red rectangles, every 19.2 inches, indicated by teeny black diamonds. 24, 32, and 48-inch centers are multiples of the previous centers and use the same indicators. When spaced properly, floor and wall panels will have framing material on each end for fastening, with some of the center available for the next sheet. If you pull the tape out to 8 feet, you'll see that all 3 indicators share this location. This is because 8 feet is a multiple of all conventional spacing. Okay, let's go on to tips, tricks, and ways to use a tape measure. Marking with the hook. If you're in a spot where there's no place to hook the tape measure, you can place the desired measurement on a reference line and use the hook to mark the second line. This method is helpful while on a ladder. You can save yourself a trip down the ladder or off the roof if you learn to use the hook to pick up dropped items. With the addition of a magnet, you can pick up a whole lot more. A tape can be used to scribe a line. The front edge of the tape rides against the workpiece, so non-rubberized models slide a little more easily. Lock the blade to the correct distance and scribe. A tape can be used as a slide rule. I'll use a simple example. Let's subtract 3 from 14. You pull out the tape just beyond 14 feet, hold the hook at 14 feet, and slide down to 3, and there it is, 11 feet. This can be used with fractional measurements just as effectively. Addition with a tape and a flat ruler. For example, you can add 2 3/4 to 3 5/8 by holding the 0 point of the ruler at 2 3/4 on the tape and reading the tape where the ruler reads 3 5/8, and you can see that it adds up to 6 3/8. You can measure with the middle of the tape. For example, if you start at 3 feet and you measure to 6 feet and a half an inch, the actual measurement is 3 feet and a half an inch. I most often use this method when I need to measure on the ceiling, but I don't have a ladder. It can be difficult to mark a line around the circumference of a piece of pipe that's 90 degrees or perpendicular to the length of the pipe. But if you take a tape measure, wrap it around, squeeze it tight, and align the edges, you'll get a mark that's pretty close to perpendicular. You can use a tape measure as a straight edge. The blade of the tape is rigid enough to be used as a straight edge. Locate your blade, pull tight, and strike a line. I don't usually go beyond 4 feet, but in a pinch, you could go farther. The tape measure as a compass. The hook slot is great for drawing arcs and circles. Place the nail at the center of your circle and choose your radius and draw. Here's an example of several different arcs. I think I did these 4 inches apart. The thickness of the shaft of the nail has an effect on the radius and must be accounted for during operations that require a high degree of accuracy. Now that you have a straight edge and a compass, you can do geometry, like bisecting a line and finding square. To bisect a line, or in other words, to cut a distance in half, drive a nail at each end of the line and swing arcs to create 2 sets of crossing lines. Then draw a line through these crosses. This cuts the distance in half and creates square corners. Finding the middle of a board. First, you can measure the board and then bring the hook around to that measurement. Find the bend of the tape and look for the middle of that bend, and that's the measurement. In this case, 16 5/16. Next, you can just pull 2 tapes, opposite directions on the piece of wood, and find where they read the same. The next method is to pick an arbitrary distance, in this case 15, and measure both directions and mark. Now that you have a small section, it's easier to do the math. In this case, it's 2 5/8. Half of 2 5/8 is 1 inch and 5/16. And of course, you can do the math. Half of 32 5/8 is half of 32 and half of 5/8, which is 16 5/16. Bending the rule. Divide something into any number of equal sections. For example, if you want 5 equal sections, pick a number that is easily divided by 5 and is close to the width of the entire object. In this case, the plywood's 48. We'll use 50 and swing the tape until 50 intersects with the edge. Then mark at 10-inch multiples. Do the same at the other end and connect the dots. You can check to see if a frame is square by checking the diagonal measurements. If the measurements are the same, the frame is square. If not, adjustments can be made and it can be checked again. This method can be used with panels too. There is one caveat. The opposing sides of the rectangle need to be the same length for this to work. In other words, this only works with parallelograms. The 3-4-5 method for square. Measure out to 3 units in one direction and 4 units in the other direction, then connect the 2 marks at 5 units. When all 3 numbers are correct, it creates a triangle with a 90-degree corner. This works with multiples of 3, 4, and 5, so 6, 8, and 10, 9, 12, and 15 work. You can use inches, feet, 16-inch centers, and so on for this method. I use it almost daily while building homes. So now let's talk about fractions, which are the little intimidating lines between inches. But in order for you to really understand why these lines are here and how to use them, I want you to think of a tape measure as a stick with lines on it. Let's start with a blank stick. If you need to measure something, you can use a stick and mark it, then transfer the mark to your work. I'm showing you this method to illustrate that lines and numbers on the tape measure are not necessary, but they are a lot more convenient. This method works well, but the stick will soon fill up with lines and make it difficult to read. So to solve this problem, we add a bunch of equally spaced marks to our stick, hoping that our marks will line up to whatever it is we have to measure. This way we can reuse them. But now we have a new problem. How do we remember which line to use? One solution would be to number them. Now we can remember the lines by going to the number. Let's call these inches. What if the thing we're measuring lands between the lines? We could add more lines and numbers, but that's cluttered and confusing. So instead, let's start with a mark halfway between the inch marks. We can call it half of an inch and refer to it as 1/2 beyond the previous number. For example, this is 1.5 and this is 4.5. Now we don't need numbers for reading these lines because they're read in the context of the previous inch. Soon we find we could use even more lines, so we cut the space between the lines in half again. This makes 4 equal spaces inside of an inch, effectively quartering the inch. We can call these 1/4, 2/4, referred to as half an inch, 3/4, and the 4th quarter is the next inch. Every fraction on the tape measure has a preferred written form and always has an odd numerator. This may be 2/4, but it's written as 1/2. 1 being odd. Watch for this pattern as we move on. We decide we need more, so we carry out the same operation and cut the new spaces in half again. This makes 8 equal spaces inside of an inch, or 1/8 of an inch, 1/8, 2/8, or 1/4 inch, 3/8, 4/8, or 1/2 an inch, 5/8, 6/8, or 3/4, and 7/8. The final 1/8 is the next inch. And here are the odds again. This is still not enough, so we carry out the same operation one more time, cutting the new spaces in half again. This makes 16 equal spaces, or 1/16 of an inch. We can refer to these as 1/16, 2/16, or 1/8 of an inch, 3/16, 4/16, or 1/4 inch, 5/16, 6/16, or 3/8, 7/16, 8/16, or 1/2 an inch, 9/16, 10/16, or 5/8, 11/16, 12/16, or 3/4, 13/16, 14/16, or 7/8, 15/16, and finally, the last 16th is the next inch. And as you can see, all the numerators are odd. So you may be asking, how can I tell at a glance if the line is a 1/16, an 1/8, a 1/4, or a 1/2? The shortest line is a 1/16. The lines the next size up are an 1/8. The next size up is a 1/4. And finally, the largest is a 1/2 an inch. And of course, the 1-inch lines go all the way across the tape. I hope that all made sense. And remember, it takes practice to be proficient with a tape measure. If you need to buy a tape measure and you want to show some support for this channel, I'll have affiliate links in the description. And if you think I earned it, please subscribe.